Come over here. Wu Yanzu has something interesting to show you. Look at this loader bucket pin shaft. The wear and tear on this part is as severe as a 3-bedroom apartment. But the masters say it can be restored to like new condition and even comes with a 3-month warranty. However, upon disassembling it, we found that the bushings inside were completely worn out. The wear on the pin shaft has also reached a very severe level. If this kind of condition can still be repaired, then it's almost like manufacturing it from scratch. Before starting the actual repair, the master will carefully clean it with gasoline, scraping off all the oil sludge and various dirt stuck on it. After this careful cleaning process, the specific degree of wear becomes clearly visible. Those unfamiliar with the situation might even think those recessed areas were designed that way. In reality, those indented spots are entirely caused by long-term wear and tear. However, in Pakistan, they are already used to seeing such severe wear. Of course, facing such significant wear, if they directly use welding to repair it, to save welding rods, they came up with a clever idea. Using the steel bars in front of them for the repair. First, they precisely measure and select steel bars of roughly the same length as the grooves. Then use cutting technology to precisely cut according to the pre-marked positions. After cutting the steel bars to equal lengths, they can be placed into the grooves, preparing for the welding operation. During this welding process, the master did not take any protective measures at all, surprisingly handling it directly with his hands, as if he didn't feel the heat at all, as if he had become immune to welding, truly an iron hand without mercy. After placing the steel bars around the groove, the master continues to use welding to build up the welds on top, little by little, stacking the welds until the grooves are completely filled. As time goes by, the weld gradually fills up, forming a solid and smooth welded surface. Only then is this round of build-up welding completed. After 2 careful welding operations, the severely worn part now appears to have achieved a seamless fit. However, this still cannot be considered truly complete. It is indeed difficult to detect with the naked eye, but this experienced master, with his keen left eye, noticed it. Therefore, the master needs to further use welding to perform a comprehensive build-up weld over the entire surface of the pin shaft. After 30 long minutes, the current round of build-up welding was finally completed successfully. However, the surface still appeared uneven. Next, the master needed to mount this welded part onto a lathe. Carefully and skillfully, he secured it, ensuring it would not become loose or shift during the subsequent machining process. Then, the lathe started up, and the tool slowly approached the edge of the part. Bit by bit, the tool cut away, with metal shavings gently falling down. The master focused intently on the machining process, occasionally adjusting the lathe's parameters to ensure the precision and quality of the cutting. However, it was evident that even after the series of previous treatments, the pin shaft had not yet achieved the required smoothness. Therefore, the master needed to use an angle grinder for a detailed grinding and polishing operation on the surface. After a careful polishing, the entire pin shaft now looks just like new. The master's superb craftsmanship truly deserves praise. Next, the production of the bushing begins. The iron pipe in front of us is the material for making the bushing. Since there isn't a suitable cutting tool available at the moment, the master first turns a groove on it as a marker. Then, using a cutting tool, he makes a precise cut along this marker. After this cutting operation, the required size is obtained. The cut piece is then placed back on the lathe for a new round of machining. The master first turns the cross-section to make it flat and then starts turning the outer edge. It is important to note that this outer circle is not a uniform standard circle. In the middle, a grease groove needs to be intentionally left. This ensures that during subsequent greasing, sufficient lubrication can be achieved. Next is the turning of the inner hole, which needs to be sized to match the pin shaft perfectly. After the hole is properly machined, the bushing is then rotated to machine the areas that were not previously addressed, ensuring a complete and precise finish. This sleeve is considered finished, just like this. Next, it can be installed onto the shaft housing. There's a certain skill involved in installing this sleeve. It's necessary to precisely align the grease hole with the grease hole on the shaft housing. Otherwise, subsequent greasing won't proceed smoothly. After installation, you can observe obvious worn gaps remaining on the shaft housing. As for these gaps, the master plans to use a metal plate to insert into the crevice for repairs. For those finer areas, use welding rods to insert into them. Anyway, the goal is to fill the gaps completely. After roughly filling in the repair, proceed by welding along the edges using build-up welding. This will firmly secure the entire lining sleeve in place. After welding is complete, it's necessary to use an angle grinder to polish the entire piece meticulously, striving for perfection. This demonstrates what true craftsmanship is, unlike the mediocre work seen elsewhere. During the welding process just now, some welding slag inevitably flew into the holes. Therefore, the master now needs to use a straight grinder to clean out the welding slag from inside the holes. After cleaning out the slag, insert the shaft pin for a test fit. Once it's checked and confirmed to have no issues, you can proceed to install it onto the bucket. A shaft pin repaired like this should remain undamaged during subsequent use.